Very good afternoon to all. Okay, I welcome you all. This is another lecture of our subject Industrial Hydraulics and Pneumatics, that is IHP. In the last lecture, we were discussing about the types of the pump, and in the last lecture, we have discussed the vent pump. Okay, and under vent pump, we have seen that unbalanced type vent pump and balanced type vent pumps. Okay, and again in that balanced pump, we have seen that constant displacement balanced type pump and variable displacement pump. Now today, the what are the remaining type of the pump that we will see. Okay, so now as per the types of the pump, we have firstly gone for the gear pump, and yesterday when we have seen the vane pump. Now we'll go for the third type, that is the piston type of pump. Okay, piston type pump. Okay, now under this again piston type pump, we'll have the two types. Okay, subtypes. Okay, one is the radial piston type and another is the axial piston pump. Okay, and this axial piston further classified into two types. Okay, and that two type means what? One is the swash plate type axial piston pump, and second one is the bend axis type axial piston pump. Okay, so one by one we'll go for its construction, working, and diagram of the each and every. So we'll start with the radial piston pump. Okay, now before discussing this radial piston pump, let me confirm that whether my voice is audible at your end, whether a screen is visible at your end. Just tell me in chat box. In the chat box, you can write yes, no, so that I can continue. In chat box, just tell me. Okay, so see, this radial piston pump has a number of radial pistons. Okay, as we know that in similar fashion to the our spoke of the wheel. Okay, we have the wheel of the cycle, and in that spokes of the wheels are arranged like this. So what are the arrangement in this radial piston pump? What are the done now? So that arrangement is a similar to the our spoke of the wheel. Okay, in a cylinder head, this what are the I have shown now. This radial piston, you can see this 1, 2, 3, 4, 5. So all the this radial pistons, okay, that are placed in a cylinder block. You can see cylinder block. This is a cylinder block, you can see, and this all the pistons will revolve around this stationary eccentric cam. Stationary eccentric cam. So this is our stationary eccentric cam. Okay, which is placed here. Okay, this what is cylinder block, and these are the piston 1, 2, 3, 4, 5. Getting it? And at the center you will get the eccentric cam, and this eccentric cam is stationary. Okay, and around these your this all the pistons are revolved. Okay, and in this pump, actually in this radial piston pump, what happens? The piston, all the pistons will move perpendicular to the shaft center line. Okay, you can see here we have the shaft center. So perpendicular to this shaft center, your piston will move. So you can see if piston one will move like this, then second like this. That means it is perpendicular to that center line of the piston. Center line of the shaft. This one also it will move. All the pistons will move perpendicular to the shaft center line. Getting it? So this is a specialty of this radial piston pump. Getting it? And as the cylindrical block rotates, as the cylinder block rotates, the eccentricity of this cam, okay, it causes the in and out or we can call pumping action or pumping motion of the piston. Okay, as the cylinder block rotates, that time the eccentricity of the cam, it will causes the in and out, or you can call the pumping motion of the your piston. That means pumping motion of this piston. Okay, in and out. Okay, and this is actually it is called the working principle of the our radial piston pump. Okay, so you can see here we have for each and every piston will have this wall, and this through wall you will get the fluid inside this. You can see the direction also. Okay, for this. Okay, so you can see for this one and this one, you will get the fluid inside. Okay, it will take under this, and then it will goes outside. That means it exists from this tube cylinder. Getting it? So as you could be able to realize the working of the this radial piston pump. Getting it? That means the fluid will start to come inside. That means fluid inflow, and it will happen in this two cylinder. Okay, in this two piston, you can see its direction. Okay, and outflow at this each piston. Okay, outflow will happen at this two piston. Okay, and that is controlled through the uh, this revolving ports. Okay, and during the what are the downstroke is there, no? So during that, each piston is connected to the flow inlet. Okay, during the downward stroke, no, that downstroke, each piston is connected to the fluid inlet, and hence the fluid is drawn inside this cylinder. Okay, fluid is drawn inside this your cylinder, and during the upward stroke, each cylinder is connected to this fluid outlet. Okay, during the upward stroke, each cylinder is connected to the this to the your fluid outlet, and due to that, fluid is discharged uh, from this pump. That means fluid will discharge outside the pump. Getting it? So that is the working principle of the radial piston. Getting it? Okay, just have a look on the diagram so that you will get the answer. Now here itself I will tell some the advantages of this piston pump also. Okay, as we know that piston pump having the radial and the another uh, axial piston pump. Okay, but okay, radial and axial. So here I will tell some of the advantages of this piston pump also, because here first advantage is that these piston pumps are capable of delivering the high operating pressure. Okay, these piston pumps are capable for delivering the high operating pressures. Getting it? Then another advantage is that they can handle oils in a wide viscosity range also. Okay, then they can handle liquids which are containing the vapors and gases also. Okay, they can operate a variable delivery of the liquid also. Okay, again another advantage of this piston pump is they are self priming pump. Okay, no need to provide external uh, device for the priming. Okay, they are quite in operation also. They are exceptionally their work lifelong. Okay, but along with the advantages for this piston pump, we have some disadvantages also. And what are that disadvantages? They trends to the heavy and bulky. Actually, they tend to be heavy and bulky. Okay, they have the that pulsating discharge also. Okay, and the power pumps. Okay, what are these power pumps that cannot be operated against a closed discharge? Okay, hence due to that only relief valve are required. Okay, relief valves are required, and most most types of these piston pumps, they require inlet and discharge valve. Okay, so these are the some disadvantages of this. Okay, now one small video I'll show. Okay, about this radial. Then we'll continue about this point. Okay, just wait. I wanted to show. radial piston. Okay.
Radial pumps are designed so the pistons stroke in a direction at right angles to the shaft.
Whether video is clearly visible. Okay.
The pistons are
video
arranged like wheel spokes around a cylinder block with an
whether video is clearly visible at your end, just tell me in the chat box.
Yes,
Okay.
sir.
Okay.
Yes,
Okay.
sir,
Thank
it
you.
is.
eccentric central cam mounted on a drive shaft. As the shaft rotates, the cam moves towards the pistons, forcing them down into the cylinder block and discharging the fluid. As the cam moves away, springs help retract the piston and cause the intake stroke. Check valves ensure that fluid only enters the inlet ports and only exits the outlet ports. Radial piston pumps have a low noise level, very high loads at low speeds, and high efficiency.
Okay, I will show once again.
As the shaft rotates, the cam moves towards the pistons, forcing them down into the cylinder block and discharging the fluid. As the cam moves away, springs help retract the piston and cause the intake stroke. Check valves ensure that fluid only enters the inlet ports and only exits the outlet ports. Radial piston pumps have a low noise level, very high loads at cam mounted on a drive shaft. As the shaft rotates, the cam moves towards the pistons, forcing them down into the cylinder block and discharging the fluid. As the cam moves away, springs help retract the piston and cause the intake stroke. Check valves ensure that fluid only enters the inlet ports and only exits the outlet ports. Radial piston pumps have a low noise level, very high loads at low speeds, and high efficiency.
Okay, so this is about the radial pump. Okay, now let us move towards another type of piston pump, that is a axial piston pump. Okay, axial. Now, before going to this axial piston pump, let me tell the one thing that these piston pumps are available. Hello. These piston pumps are available with the different capacities, like the discharge pressure. What are the discharge pressure is there? No, so its range is the 70 bar to the 1400 bar. Okay, up to that range, this piston range piston pumps are capable. Okay, so and in addition to that, these pumps can operate at a speed over the 2000 RPM also. Okay, so please keep in mind this positive point of. Come to this axial piston pump. Okay, axial piston. Okay, so in this axial piston pump, what happens actually, the rotary shaft motion is there. No, so that rotary shaft you can see in this figure also. So the rotary shaft motion is converted to their axial reciprocating motion. Okay, in axial piston pump, what happen, rotary shaft motion is converted to axial reciprocating motion, and which drives your piston. Okay, rotary shaft motion is converted to axial reciprocating motion, and which drives your piston. And most of the axial piston pumps are multiple piston designs. Okay, multiple piston designs are used in the most of our axial uh, piston pumps. Okay, and they utilize the many times they utilize the check walls or the port plates, okay, to direct your liquid flow from inlet to the your outlet port. Okay, that means from inlet to your discharge. For that purpose, to direct your liquid flow, check walls are used. And at output that can be controlled by your different mechanism. It may be the manual, it may be mechanical, or the pressure compensated controls also. Okay, so that you can control. Now first I will discuss this swash plate type axial piston pump. Okay, swash plate axial piston type one. Okay, and this axial piston pump, in that this pistons are, if you see, no, so the pistons are in line with the your axis of the shaft. You can see we have the axis of the shaft like this, and you can see this purple color. These are the pistons, 1 2 3. So the pistons are in line with the axis of the your drive shaft. Okay, and that is I have shown in this figure. Okay, and as I have shown in this figure, you can see the rotary drive motion is there. No, so that is converted rotary drive motion, drive shaft, you can see. Okay, and in line with that, your pistons are connected. Okay, so pistons are in line with your drive shaft, getting it. And here your drive piston, that rotary drive motion is there, no, that is going to convert it into the reciprocating and axial piston motion, that can be converted to the swash plate. Okay, okay, so these are the, here you can see the swash plate is there. Okay, and that is mounted, that swash plate that is mounted on the our drive shaft. Okay, that is mounted on the drive shaft. And thus the rotation of this swash plate, no, rotation of this swash plate, that produces in and out motion of this piston, in and out motion of this piston. Okay, due to the rotation of the swash plate, which is mounted on the drive shaft, due to that the in and out motion of the piston that will produces. Okay, and that in and out motion that will be in their cylinder only. Okay, and hence your fluid will be discharges, getting it. Okay, fluid will be discharges. Now again, it's a small video I will show for better understanding. Okay, here just I have shown the colorful diagram, swash plate type axial piston pump. Okay, swash plate.
A swash plate is a device used to translate the motion of a rotate shaft into the reciprocating motion of a piston.
This is a drive shaft.
Swash plate piston pumps have a rotating shaft connected to
Okay, see, that is a drive shaft. Okay, and
a cylinder block
we have the cylinder block there,
containing pistons,
and these are the different pistons. Okay, which I have shown in the figure by that purple color.
which are pressed against a stationary swash plate
Swash plate. Okay, which is mounted on that shaft.
that sits at an angle to the cylinder. As the shaft
See,
rotates, the pistons move against the swash plate, causing them to reciprocate within the piston block. Swash plate piston pumps have a rotating shaft connected to a cylinder block containing pistons, which are pressed against a stationary swash plate that sits at an angle to the cylinder. As the shaft rotates, the pistons move against the swash plate, causing them to reciprocate within the piston block. The pistons create a vacuum that forces fluid in during half a revolution and expels fluid during the other half. On the intake stroke, a spring ensures the pistons pull back and maintain contact with the swash plate, causing fluid to fill the empty cavity left behind. On the discharge stroke, the angle of the swash plate forces the pistons back inside the piston block and discharges the fluid. The greater the slant on the swash plate, the further the pump pistons move and the more fluid they transfer. Piston pumps, in general, are manufactured with closer internal fits than other pumps. This means that back inside the piston block and discharges the fluid. The greater the slant on the swash plate, the further the pump pistons move and the more fluid they transfer. Piston pumps, in general, are manufactured with closer internal fits than other pumps. This means that internal slippage can be less so that they operate with reasonable efficiency at pressures both too high or too low for the operation of other pumps. A swash plate is a device used to translate the motion of a rotate shaft into.
Okay, I hope you got the point. Now let us discuss the another one. Again in this axial piston pump, no swash plate. Again in that you can classify it as a fixed displacement inline axial pump and a variable displacement inline axial pump. That is your swash plate design. Okay, variable displacement inline axial pump. Okay, that is your swash plate design. Okay. Now we'll go for the another one, that is this one, bend axis tap axial piston pump. Okay, so here I have shown the a typical figure of the our bend axis type axial piston pump. Okay, bend axis type axial piston pump. Okay, line sketch diagram I have shown here. Okay, so actually this type of pump, it contains a cylinder block. Okay, you can see the cylinder block is there. Okay, so this type of pump, it contains a cylinder block which is rotating with the your drive shaft. You can see the drive shaft is there. Okay, and as I have shown in this figure, no, this central line of this piston cylinder block, central line of the cylinder block is set at a offset angle which is relative to the your central line of the your drive shaft. Okay, once again I am repeating, the center line of this your cylinder block, center line of the cylinder block, it is set at an offset angle relative to the your center line of the drive shaft. Okay, center line of the drive shaft, and the your cylinder block has a number of pistons. Cylinder block has a this is your cylinder block. Okay, you can see here this cylinder block has a number of pistons. Okay, and the cylinder arrangement has done along the your that circle, along the circle. You can see the along the circle, and the ball and socket joint. You can see there ball and socket joints are there, and that connect the piston rod with the your drive shaft flange. Okay, this drive shaft flange is there. Okay, and here a ball and socket arrangement is there. Okay, due to that only the piston rods are connected to your drive shaft this flange. Okay, and when here the when distance between the your drive shaft flange and your cylinder block is there, no, so when that distance is changes, no, that time your cylinder will move inside. okay, will move inside. Getting it? And that in and out of the cylinder, so piston will move in and out of the your cylinder. Okay, and in order to actually to provide the alignment and the positive drive, no, okay, the universal line is used. Universal line is used here to for what purpose? To connect this block to this your drive shaft. Okay, to connect your this block, cylinder block, to connect with this drive shaft. Here universal line is used. Getting it? And here this is a diagram. Okay, what are the shaft plate is the same is there, but here your drive shaft and your pistons are connected with the help of the coupling, but that are inclined. Okay, that is a bend. Due to that only bend axis type axial piston pump it is called. Getting it? And here the how that operation works. So about that, when the piston carrying body is there, no, when that turns, no, that time the exit passage in the cylinder is there, no, so that bore, whatever the bore is there, no, so that will move, okay, along the your control slots of the your positional control. Alternatively, your suction and that discharge pipelines, okay, in that the suction and discharge will happen. Getting it? Again, about this bend axis type axial pump, again it having the sub type, that is a piston displacement, that is constant displacement bend axis piston pump, or another one is the variable displacement bend axis piston pump. Getting it? Okay. So again, for this also I will show one small video so that it will be easy to understand the working of this. Bend axis.
An axial piston pump is a pump that has a number of pistons in a circular array within a cylinder block. There are two designs are most relevant, the swash plate configuration and the bent axis configuration. In both cases, the angle, the swash plate or the bent axis mechanism, determines the effective stroke of the piston. Bent axis pumps design. In a bent axis piston pump, the cylinder block turns with the shaft but at an offset angle. The piston rods are attached to the drive shaft flange by ball joints. Most bent axis piston pumps consist of a few basic components: port plate, spherical siding surface, drive flange, drive shaft, shaft seal, flange, retaining rings, housing, bearing, piston, axis, cylinder block. The bent axis mechanism is a pumping machine, the displacement pistons of which are arranged at an angle to the drive shaft axis. As the drive shaft rotates, the cylinder block is caused to rotate by the pistons. The pistons move up and down within the cylinder block bores. The length of stroke is dependent on the angle of the bent axis. Fluid is fed to the low pressure, then, as the pistons moves, delivered into the high pressure port. Swash plate piston pump design. Most swash plate piston pumps consist of a few basic components: flange, shaft seal, bearing, swash plate, drive shaft, piston, cylinder block, housing, port plate. The swash plate mechanism is a displacement mechanism, the displacement pistons of which are arranged axial to the drive shaft. The reaction force of the pistons is carried by the swash plate. As the drive shaft rotates, the cylinder block is driven by means of spline. The piston pistons of which are arranged at an axis. Drive flange, drive shaft, shaft seal, flange, retaining rings, housing, bearing, piston, axis, cylinder block. The bent axis mechanism is a pumping machine, the displacement pistons of which are arranged at an angle to the drive shaft axis. As the drive shaft rotates, the cylinder block is caused to rotate by the pistons. The pistons move up and down within the cylinder block bores. The length of stroke is dependent on the angle of the bent axis. Fluid is fed to the low pressure, then, as the pistons moves, delivered into the high pressure port. Swashplate piston pump design. Most swashplate piston pumps consist of a few basic components. Flange, shaft seal, bearing, swashplate, drive shaft, piston, cylinder block, housing, port plate. The swashplate mechanism is a displacement mechanism, the displacement pistons of which are arranged axial to the drive shaft. The reaction force of the pistons is carried by the swashplate. As the drive shaft rotates, the cylinder block is driven by means of spline. The pistons move up and down within the cylinder block bores. This movement is dependent on the angle to the swashplate. Fluid is fed to the pump via the low-pressure side, then as the pistons moves, delivered into high-pressure line.
In this video, I explain straight axis piston pump.
So, up till now, we have discussed the gear pump, vane pump, and then piston pump. Okay. Now let us go for the comparison of these three pumps. Okay. Vane pump, sorry, gear pump. Under that, we have seen the external gear pump, internal gear pump, globe pump, and then we have gone for the that Joe rotor pump. Okay. Under vane pump, we have gone for the balanced vane pump, unbalanced. Okay. And under piston pump, we have seen the radial piston pump and axial piston pump. Getting it? Now we'll go for the comparison of these three pumps. Okay.
In this video, I explain comparison between gear pump, comparison between gear pump, vane pump, and the piston pump. So first comparison is based on the constructions. So here we mention the point of gear pump, in middle vane pump, and on the right side that is a piston pump. So first comparison is based on the constructions. Okay. So before moving on the point of constructions, here you see this is the image of three pump, that is the gear pump, vane pump, and the piston pump. So if we understand from the figure, then it is very easy to understand. Okay. So in a gear point, it consists of a two gear in a mesh with each other mounted inside a closed casing. So here you see this is the casing. Okay, this is the casing, and inside this casing the two gear are used. These gear are either the spur gears or a helical gears, and they are in a mesh. Here you see that two gears are in a mesh. Out of these two gear, one is the driver and another is a driven. Means one gear is rotated by using the prime mover. Prime mover means it is either electric motors or a IC engines, and another gear means second gear is rotated due to this meshing with the driver gears. Here you see this is the vane pump. So vane pump is consist of cylindrical rotor with radial slots. Vanes are inserted in the slots. So here you see this gray color portion is the rotor. Okay, and inside the rotor that is a various ball is created. This ball is also called as the hole or a radial slots. So here you see that is a 1, 2, 3, 4, 5, 6, 7, 8 radial holes is provided or a slot is provided, and inside these slots the vanes are inserted. Here you see this the dark gray color is indicating the vanes are inside the slots. The rotor is mounted with an offset in a casings. So here you see this is the casing. Okay, so casing center is here and the rotor center is here. Okay, so this center distance between this center of the rotor and the center of the casing is called as the offset. Here the point of the piston pump, it consists of a cylinder block with axial or radial boards. Piston are inserted in these boards. Here you see this is the cylinder block. This blue color portion is the cylinder blocks, and inside this cylinder block the boards are created. Board means holes are created, and inside this board here you see this the pistons are inserted. Here the piston is up to these points and here the piston is up to here. Okay, so this is the piston. One end of the piston is connected to the rotating components. So one end of the piston is inside the boards and another end of the piston is with the rotating component, means with the shoe plates, and piston and shoe plate is connected by using the spherical joint. Now before moving on to second points, I request to visit the playlist. Now second point is on the basis of the working or a functions, means how it's work. When the driver is rotated by means of any prime movers, driven will also rotate. Means one gear is connected with the prime mover. Suppose we consider that this is the driver gear and it is connected with this prime mover, means electric motors. And we start the electric motor, this driver's per gear is start to rotate, and with this starting of this driver gear the driven gear is also rotates, and due to these rotations the oil is sucked and the trap between the gear teeth and the casing and carried from inlet to outlet. Here you see this is the inlet arrow. Okay, so when this gear is start to rotate, the inlet of the oil is done here, and this oil is passed from the space between the teeth and the casing, means oil is enter here and it's moved towards the outlet. Same way on these sides, oil is enter from these sides and moving to the here. So this is the working of gear pump. In a vane pump, rotation of cylindrical rotor cause the size of the pocket to grow continuously one end side to the and reduce to the another sides. Means during the studying the vane pump, we divide the vane pump in a two portion, left side and the right sides. Okay, here you see it is the suction. Okay, so oil is enter from these portions, and here you see this pocket side is the smaller, means pocket means it is the space between the casings and the rotors. Then here you see it's the pocket size is increasing. Okay, then after towards the delivery, the pocket side is start to reduce, because when we on a delivery side we require the higher pressure, so we need to reduce the size. This cause filling of oil on a suction side and delivery of oils on the another sides. Means oil is filled on the suction sides and delivered from this delivery sides. In a piston pump, rotations of the moving component cause the piston to reciprocates in the boards. So here you see this is the shaft. Okay, so this driver shaft is connected with these prime movers. So when the prime mover is start, this driver shaft is also start to rotate, and this shoe plate is also rotate, and when the shoe plate is start to rotate, the cylinder block is rotate, and this piston is start to reciprocate inside this bores of the cylinder. Half rotations of the cylinder block cause suction of oil into a bores, and next half is caused the discharge, means 180-degree rotations of the shaft. The suction is takes place from these sides and the discharge is takes place from these sides. Now the third comparison is between the pressure, discharge, speed and volumetric efficiency. Gear pump is generally used for the pressure range of 35 to 200 bar. Vane pump is used for the pressure range of 70 to 140 bar, and the piston pump is used for a pressure of 140 to 850 bar. For a discharge, gear pump is used for discharge of up to 45 meter cube per hours. Vane pump is used for discharge up to 20 meter cube per hours. Piston pump is used up to 45 meter cube per hours. What is the RPM of the gear pump? Gear pump RPM is 1200 to 2500 RPM. Vane pump RPM is 1200 to 1800 RPM, and the piston pump RPM is 1200 to 1300 RPM. And volumetric efficiency of the gear pump is 80 to 90%. Vane pump volumetric efficiency is 90 to 95%, and the piston pump volumetric efficiency is 95 to 98%. Okay. So we see this the also the selection criteria for the various types of the pump. Suppose we require the 100 bar pressures, then we have the two options. Either we select the gear pump or a vane pump. Suppose we require the 30 meter cube per hour of discharge, then we have the two options. Either use the gear pumps and the piston pumps. So from this data we are also able to select the which type of the pump is required according to this our criteria. What is the volumetric efficiency is required, means highest volumetric efficiency is for the piston pump, that is the 95 to 98%. So thank you for watching this video. If you learned something, then like the video.
So that is about the comparison. Okay, now we are familiar with the gear pump, vane pump and the piston pump. Okay, now that pump is clear. Now let us go for the another point, that is hydraulic pump characteristics. Okay, so about this point we'll discuss now. Okay, so the control factors for this pump, for this pump. Okay, so under the control factors for the hydraulic pump, you can consider the discharge pressure and the volume of the fluid. Okay, that are the that means volume of discharge pressure and the volume of the fluid. That are the that will fix your, or that will give the information of the speed of the operation and the load on the pump. Okay, that means the which are the control factors for the pump. That time you should remember this point: discharge pressure, volume of the fluid, then a speed of the operation and the load on the pump. Okay, then what are the we have the pumps of different types. Okay, pumps of the different types. So that will operate differently. Okay, because for every pump it's having some specialty, it's having some positive point and negative. So that all the different types of pump will operate differently under similar conditions. Okay, for example, I will tell the one example, that the effect of discharge pressure. Okay, what are the pressure is there at discharge? That means the effect of discharge pressure on pump output. That may differ between your positive and positive displacement and non-positive displacement pump. Okay, so that is a behavior or the characteristics of that different pumps. Okay, and what are the behavior of the pump is there, under the various or under the varying condition that we'll discuss using the characteristic curves of the pump. Okay, behavior of the pump under varying conditions, that is mean the pump characteristics, and that we'll see with the help of some graph. Okay, I will show the first graph, pump characteristic for that. Now you can see this first graph. Okay, pump discharge pressure versus rate of discharge. Okay, so this figure explains us that the relationship between our pressure, okay, or the head which is produced by the pump. Okay, pressure or the head which is produced by the pump, and the rate of discharge, when the pump is running at a constant speed. So you can see output pressure, that means your discharge pressure. Okay, and here discharge rate of discharge is here I have shown. Okay, you can see delivery, that means the rate. Okay, rate versus output pressure, discharge pressure, and here rate of discharge at a constant pump speed. Pump speed here, that pump is running at a constant speed. See, that means, okay, now from this figure or from this graph, it implies that, or it is clear that pressure to be delivered, okay, when that pressure is less, no, so that less, when the pressure is less, that at the discharge. Okay, so at that outlet pressure, when it is less, that time, okay, you can see here value is less at starting, that times your rate of discharge is more. Okay, if outlet pressure, that means if pressure to be delivered, if it is less, that time your rate of discharge is high. Okay, and if your discharge pressure is high, that time your delivery rate is less. Okay, so that is called the characteristic. And this first graph I have shown pump discharge pressure versus rate of discharge. Okay, now let us go for another one. Here, pump discharge pressure versus power efficiency and rate of discharge. Okay, so this chart is used for determining the pump power requirement. Okay, pump power requirement. Okay, so this figure tells us that how much power must be supplied to your pump. Okay, how much power must be supplied to the pump for what purpose? To obtain the different rates of the discharge. Okay, to obtain the different rates of discharge, how much power should we supply to your pump? Okay, okay, that to obtain the different rates of the discharge against your different discharge pressures. So here you can see the discharge pressure, that is the this delivery pressure, and here we'll have the this power. Okay, so if you look at this graph now, that then it tells that, or it is clear that when more power is required, no, that means it is clear that more power is required to deliver. Okay, more power is required to deliver the higher discharge pressure. Here we can see the discharge pressure, here line is there, that means here power delivery pressure is high, that means the discharge rate is also, that discharge pressure is also high. Okay, more power. Okay, this value you can see, if more power is there, okay, that means more power is required to deliver this higher discharge pressure. Okay, and thus this curve also gives that gives information about the volumetric efficiency also. Okay, and the mechanical efficiency at different discharge pressures. So you can see we have the discharge pressures, and it's a delivery pressure, volumetric efficiency you can see, and mechanical efficiency also you can say, okay, with respect to this discharge pressure. Getting it? Okay. Now, this figure it's related to the rotary pump characteristic. Okay, so this figure explains that the typical efficiency curve. Okay, typical efficiency curve. You can see these are the efficiency, percentage efficiency, then a power curve I have shown here. Okay, and the rate of discharge. Okay, and that's curve for it is for the rotary pump at constant operational speed. Okay, so by looking into this curve, okay, we get the point that is we can interpret that the following some conclusions. Now, which are that conclusions which we'll get from this graph? That is the first conclusion that rotary pump usually run more efficiently at lower delivery pressure. Okay, this rotary pumps usually run more efficiently at lower delivery pressure. Then another conclusion which is made from this figure is that the power necessary to run this rotary pump, no, if it is increases almost directly, so as that does the pressure, okay, produced by the pump, okay, at a constant speed. Okay, the power necessary to run a rotary pump increases pressure which is produced by the pump at constant speed. And third conclusion is that there is a relatively little difference in the rate of discharge for the delivery pressure. Okay, there is a little bit somewhat difference is there between your rate of discharge for the delivery pressures. Getting it? So that was about the rotary pump. Now, next I will show the about a centrifugal pump also. So this figure, this graph explains about the typical efficiency curve, then power curve, and the rate of discharge curve for this centrifugal pump. Okay, which will run at a constant operational speed. Again, from this graph, it is concluded that some conclusions has been made. That is, the central pumps usually run more efficiently at higher rate of discharge. Okay, these central pumps are running more efficiently at higher rate of discharge. Then another conclusion is that the rate of discharge of this central pump actually it decreases or it drops quickly as increasing the discharge pressure. Okay, that means rate of, you can see, rate of discharge, okay, of this central pump, it decreases or it drops, okay, as discharge pressure increases. Getting it? So this is about the central pump characteristic. And then last I will show about the external gear pump. Okay, so this graph shows the characteristic curve for an external gear pump. Again, this curve showing the relationship between the pump discharge pressure, you can see, which is I have taken on the x-axis, and the pump capacity, which is I have taken on y-axis. Okay, so that term actually it is named as the head capacity curve. Okay, head capacity curve, HQ curve. Head means H and capacity is the Q. Okay, again, this curve showing the relationship between the power input and the pump capacity. Okay, again, for that also another term it is used, that is power capacity, PQ curve. And by looking to this graph, it is concluded that, or some conclusions has been made. That is the first conclusion is that at any given speed, the capacity characteristic is nearly flat line. Okay, at any given speed, your capacity characteristic is nearly flat line. Then the power input increases with both both operating speed and discharge pressure. Okay, that means with respect to operating speed and discharge pressure, your power input is going to increases. And at last, the important conclusion is that at the speed of gear gear pump is increased, that time its discharge rate also increases. Okay, so these are the pump characteristics with respect to the rotary pump. We have seen the central pump, we have seen that external gear pump. Okay, now in the next lecture we'll start down our another new element, basic elements of the hydraulic system, that is accumulator and intensifier. That we will see in the next we'll start in the next lecture. Now I request you all, please write down your roll number in the chat box, and after writing your roll number in the chat box, you can leave this meeting. Thank you. Okay, see you tomorrow. Okay, after writing your roll number, you can leave this meeting, no problem. And please join another next lecture, that is meta lecture. All of you, please write on your roll number. Remaining students, please be fast. Saurabh Shende, Sontak Omkar Sarde, Rohit, Prathamesh Patil, Shubham Singhan, Rohit Zundre. Be fast.